Okay, a circle C has the equation x squared plus y squared plus 6kx minus 2ky plus 7 equals 0. They want us to find the centre and the radius. So this is a bog standard question. I'm going to write it as x squared plus 6kx plus y squared minus 2ky equals minus 7. Now what we do is we do the completing the square operation here, which means, let me just write it down, x plus 3k squared minus 9k squared. Now what I've done is the coefficient of x, which is 6k in this case, you halve that and you put that here, and whatever you put here, you square it and you write it outside. Don't put the x here as well, that's a common mistake. Now the next one is going to be y minus 1k, y minus k squared minus k squared equals minus 7. It's the same principle. If this is whatever is the coefficient of y, which is 2k, you halve it and you put it here, and whatever that you put here, you square it and you write it there. Note that this is always a minus sign. Whether or not this is a minus sign or a plus sign depends on what that sign is there. So that's completing the square. Now I'm going to collect the terms according to the equation of a circle. Equals 10k squared minus 7, because we know that if in the general case, if you have x minus a all squared plus y minus b squared equals r squared, we know this is a circle where the centre is at AB and the radius is equal to r. So therefore, to answer the question, part A, parts 1 and 2, they want the centre and the radius. Well, the centre is going to be minus 3k k, and the radius is going to be the square root of 10k squared minus 7. So that's the first part of the question. Goes on to say the line with equation y equals 2x minus 1 intersects C at 2 distinct points. Find the range of possible values of k. Right, well, we've got the line. This is part B. We've got y equals 2x minus 1. And we've got the circle, which is the equation at the top, this thing here. Well, you've got to find that where they intersect, where they meet. So what I'm going to do, I'm going to use the substitution principle, that if two things are equal to each other, then you can replace one by the other. So this y I'm going to replace by 2x minus 1. So we get this. We get x squared plus 6 kx plus y squared. Well, y is 2x minus 1, so it's going to be plus 2x minus 1 all squared minus 2 times k times 2x minus 1 equals minus 7. Then we get x squared plus 6kx plus 4x squared minus 4x plus 1 minus 4kx plus 2k plus 7 equals 0. I'll bring the 7 back. So we get 5x squared That's that and that. You've got 6kx minus 4kx. So it's 2kx plus 2kx minus 4x. That, that, that. Plus 2k plus 8 equals 0. Right, so finally 5x squared plus 2k minus 4 times x plus 2k plus 8 equals 0. Now we want to know, the idea is then, we've got this circle and we've got this line. That's not in shot, just a moment. It is now. We've got a circle and a line, and the idea is that the circle and the line meet twice. If that's the case, then this equation, because this equation, the x values of this equation are going to be the x coordinates where they intersect. So if the line and circle intersect twice, it means that this quadratic equation, it means that b squared minus 4ac must be greater than 0. Otherwise, in the equation, there wouldn't be two distinct solutions. Let me explain that a bit more clearly. Let's suppose we wanted to solve this using the formula. So we go x equals minus 2k minus 4 plus or minus the square root of b squared, which is 2k minus 4 squared, minus 4 times 5 times 2k plus 8, all divided by 2 times 5, which is 10. Well, this, if we solve this equation now, we would find the two x values, providing that this here is not equal to 0. Because if this was equal to 0, of course, there wouldn't be two solutions, because it would be plus or minus 0, it'd just be one solution. Or if indeed this was negative, of course, there would be no solutions, because the square root of a negative number doesn't exist. So anyway, so what we need is this here, what's called the discriminant, must be positive. So what we now say is that, okay, 2k minus 4 squared minus, well, that's 20, isn't it? 20 times 2k plus 8 must be greater than 0. So we've got to solve an inequality here. Anyway, let's times it out. So you get 4k squared minus 16k plus 16 minus 40k minus 160 needs to be greater than 0. So 4k squared minus 56k minus 144 must be greater than 0. Okay, so this is a quadratic inequality. Actually, we can divide through by 4, can't we? Let's quickly do that first of all. So we get k squared minus 14k minus 36 has to be greater than 0. Now we've got to solve this quadratic inequality. Now, what I'm going to do, if you think of a quadratic, let me just write this down in this form. Y equals k squared minus 14k plus 36. If you think of the graph of this, sorry, minus 36. What's the graph going to look like? Well, say the graph looks like this. The solution to the inequality is going to be where the value, the y value, is positive. So it's going to be here and here, because this is the y-axis, and this is actually your k-axis in this case, and the y value is positive, providing that the k is from here in that direction and from here in that direction. So what I'm going to do, I'm going to solve this as a quadratic equation, as if it was equal to 0. First of all, so we get k equals 14 plus or minus the square root of 196, that's 14 squared, minus 4 times 1 times minus 36, all over 2. It's not quite in shot. Which is equal to 14 plus or minus, I'll just do it on the calculator, it's 196 plus 144, which is 340 all over 2. Right, now my calculator isn't a lot of good actually. 14, I think it's going to give me a decimal. So let me just think for a second. 340. Yes, okay. So it's actually this. It's going to be 7, because 14 divided by 2, plus or minus. And it turns out that's equal to the square root of 85. I mean, hopefully your calculator is better than mine in terms of giving you the answer at once. Right, now this is the... so basically this value here then is actually 7 minus the square root of 85. And this value here must be 7 plus the square root of 85. You see, what was the question? Hang on. No, that's not the... There was something else. Oh, I can't find... Never mind. All right, I'll just carry on. Right, the range of values of k. Well, k can either be less than 7 minus root 85, or k can be greater than 7 plus the square root of 85. That's the values of k. I think that's the answer to the question. Thank you.